simply use the addition or subtraction property so that our inequality will not change. Okay, now let's move this to let's move our right hand side to the left hand side. So this is now x minus x plus 6 over x plus 2 is greater or equal to 0. Next, we know that denominator, this is 1. Okay, let's take the LCM, LCD, which is x plus 2. And then let's multiply this to this term here. So we have x times x plus 2 minus x plus 6 is greater or equal to 0. So you have to take note the parenthesis. Okay, let's distribute this one. That gives us x squared plus 2x. Distribute the negative sign. That's negative x minus 6 all over x plus 2. Okay, all greater equal to 0. Now let's simplify this one. Now we can factor this out. Let's use the FOIL method. Okay, it's x. So factor of 6, 2, and 3, that can give us 1x in the middle term. Okay, so 3, 2. Now that's positive, so let's take positive 3 and minus 2, because if we multiply the positive 3 times negative 2, that gives us negative 6. And then for the O and I of our FOIL, that's positive 3x minus 2x gives us positive x, which is the middle term. Okay, this is the factor of our numerator. Let's rewrite that here on top. This is now x plus 3 and x minus 2, then x plus 2 all greater equal to 0. So this is now our inequality to be used for our test points. Okay, now let's draw the real number line. Critical points first. So for a numerator, the zeros for a numerator, that is when x equals negative 3, and when x equals to 2, and then x equals negative 2 for our denominator. Well, let's now draw the real number line with our critical points. We'll start from negative 3, negative 2, and then 2. Again, we have 4 intervals. Yeah, let's draw the interval first. That we can sort it out already. So our 3 is at the numerator, that's included. 2 is at the numerator, so that's included. Negative 2 is not, because it's at the denominator. So that's from negative infinity to negative 3. There you go. Okay, these are our whole set of intervals. Now let's pick the critical points here. So we have negative 5 here. We can take negative 2.5. Here we can pick 0. It's easier. We can pick 3 here, 4, or whatever. Okay, so let's take this one here, negative 5. That's negative 5 plus 3, that's negative 2. So the first factor is negative. Negative 5 and minus 2, that gives us negative 7. It's negative. Negative 5 plus 2, that gives us negative. So negative times negative is positive, divided by negative, that gives us negative. And this is false here. Next, if we have negative 2.5, so that's negative 2.5 plus 3, that gives us positive 0.5. Negative 2.5, that gives us negative 4.5. Okay, this one Negative 2.5, negative is bigger, so that gives us negative. So that's positive times negative is negative, and divide negative gives us positive. So this interval here is true. Next, if we get 0, 0 plus 3, it gives us positive. 0 minus 2, it gives us negative. Then 0 plus 2, that gives us positive. Okay, so all in all, positive times negative, that's negative, divided by positive is negative. So this interval here is false. The next one is our test point is 3. So that's 3 plus 3, it gives us positive. Then 3 minus 2, that gives us positive. Then 3 plus 2, that gives us positive 5. It's positive, so that's positive. So this interval here is true. Okay, so the solution set now is the set or the intervals that's closed, that's included, negative 3. Then open at negative 2. Union, that's from 2 to positive infinity. All right.